Hello again, everybody. I'm coming to you from P-Dog Studios, where I'm recording another video for you, teaching you another one of our little tricks in chemistry. So what we're going to do today is learn how to find the empirical formula. And being the Star Wars nerd that I am, I couldn't help but make it into a little Star Wars themed presentation. So, when we were first starting to catalog all the materials that make up our world, one of the things that scientists were able to do was figure out ways to break down chemicals and figure out what percentage of each chemical or each element is in various chemicals. And then there was a way that you could take those percentages and figure out what is the actual formula for that particular compound. And so that's what we're going to be doing in this process. We have it's pretty much a step. As long as you learn your steps and go through them one after another, then you should be all right with this process. So our steps are this. We're going to treat our percentages if they're grams. We're going to convert those grams into moles. We're going to divide each one of those moles by whichever one is the smallest. We're going to look for fractions, and if we find any, we're going to clear those fractions, and then we're going to write the formula. So let's walk through an example and see how this goes. So I have here, consider a compound that is comprised of 56.95% copper, 14.37% sulfur, and 28.68% oxygen. What is the empirical formula of that compound? So here we're going to go through the steps one by one, and I'll show you each step what exactly you have to do. So step one is we're going to treat those percentages as if they are grams. Here I've written 56.95 grams instead of 56.95% copper, and 14.37 grams of sulfur, 28.68 grams of oxygen. Very simple. Just take the percentage off, put a G there. Then you're going to take those grams, and we're going to convert to moles, like we've learned to convert so many things to moles already. You do that by dividing each one of them by its own atomic mass. So here I'm dividing copper by the 6355, sulfur by the 3207, and oxygen by 16. That gives me this set of numbers, which is representative of the moles of each one of these elements in the compound, which in the end is what the subscripts on the formula are anyway. It's a mole ratio. So the next thing we're going to do is divide each of these moles by whichever one is the smallest. So here's my smallest, 0.4481. So I'm dividing all of those by 0.4481, and that gives me a 1.999, a 1.000, and a 4.000. You're going to take those then, the next step says to look for fractions. Now, fractions will become obvious a little bit later, but for right now, you're just going to trust me that there aren't any fractions there. And 1.999 is about as close to 2 as a person can get, and so that's screaming out 2. This is a 1, and this is a 4. So there are no fractional parts. It's a 1, a 2, or it's a 2, a 1, and a 4. So we don't have any fractions. We've got a 2, a 1, and a 4. So we don't have to clear any fractions, which means we can skip right ahead to the last step, step 6, and write our formula. To do that, we take the element and write the number that we found as its subscript. So this is Cu2SO4, 214, and that compound would be copper 1 sulfate. So there is the process. All you got to do is be able to go through those steps, memorize them, walk through them in your head, make little flashcards, do whatever you need to do to memorize them, but go through them over and over again. And if you know the steps, you can do this process. Let's take a look at another example. Consider a compound made up of 10.12% magnesium, 43.28% chromium, and 46.61% oxygen. And we're going to find the empirical formula. This time, I recommend you do the process as I give you the step. You go through it and pause after each time I give you a process and try it, and then you can check your answer by hitting go again or play again. So step 1 is you're going to treat your percentages as if they are grams, and I've already shown that here. Step 2 then says to take those grams and convert them to moles. So pause and see if you can do that. And now that you're back, I can show you that I'm going to convert to moles by dividing by the atomic mass, and I would get this set of values for the moles. 41.6 or 0.4163, 0.8323, and 2.9131. Next step is to divide each one by the smallest. That's correct, the smallest. And so if we do that, here's my smallest one. So I'm going to divide each one of these numbers by that, showing that. And then that would give me these numbers. Take a look and see, do you have any fractions? Hey, this is a 1. This is a 1.999 or a 2, and this is a 6.998 or a 7. So again, there are no fractions there. That's a 1, a 2, and a 7. So there we pull those so we can skip the clear the fraction step and move right into the writing of the formula, which says MgCr2O7. So this would be magnesium dichromate. Magnesium dichromate would be the compound that we're looking at here. All right. Go on one extra. This one's a little bit harder here. Consider the compound is made up of 69.94% iron and 30.06% oxygen. What would its empirical formula be? I would recommend you right now pause, try and do that, and then when you've got it done, hit play again and follow along and see how you did. So, here I've shown the calculation. You've got this guy works out to be 1.2523 moles. This one's 1.8788 moles. So when I divide both by the smallest, I get a 1 and I get a 1.50. 1.50. So now the next step says look for fractions. Well, this is clearly a 1, but 1.500. Is that 1? Is that 2? Do we round it? Do we truncate it? Well, no, you don't do either of those things. This is what that step 5 or 4 is for, looking for fractions. Here's a fraction. 0.5 is the decimal equivalent of a half. And so if that is the decimal equivalent of a half, we have found a fraction. This says that there is 1 mole of iron for every 1.5 moles of oxygen. Since 0.5 is equal to half, to clear that fraction, what we're going to do is multiply each one of these numbers then by 2. Half, 1/2, to clear that 2 out of a fraction, you multiply by 2. So instead of having a formula that says Fe1O1.5, we multiply each one of these by 2, and what we see is we get Fe2O3. So this is clearing the fraction. You find that fraction, and then you multiply everybody by a number so that that fraction will disappear and leave us with a whole number ratio, which is what we're supposed to see in a chemical formula. So all you really need is one more piece of knowledge is what are the fractions we're looking for. So look for things like a 0.25. And these are not always going to be exact. So a 0.24 or a 0.26 is trying to say, hey, I'm 1/4. So you would multiply everybody by 4. A 0.33 is a third. So you would multiply everybody by 3. 0.5 is a half, of course, we multiply by 2. And then a 0.67 or a 0.68 or 0.66, that's 2/3. So again, to clear that, we would multiply by 3. If you go on and take more chemistry, you would find that there are other things that we might come across, but in the first year class, those are the fractions that we're going to be looking for. And if it's not one of those, then there's probably a chance that you did something wrong. So back up, try the problem again, and see if you can get a different answer. So remember, learn your steps, practice them, go through them in your head so that you can write them out and follow them and step by step, and go online and search out some problems to do and practice this, and I'm sure that you can get really good at it. Thanks for, listening.